All right, here's another question on SI units. Right, so this is a question from 2015, S15, paper 2-1, question 1. Right, part A is saying use the definition of power to show that the SI base units for power are kg meter squared per second cubed. Right, so of course we're starting from definition. Right, power is the rate of doing work. Power is work done per unit time. So I'm just going to write the formula, of course. So we know that power is equal to work done. So I'm just going to write W on top there over T. Now from this we can see that power depends on work done in time. So what we need to do is to find the units for work done. So work done is equal to force times distance moved in simple terms. Okay, of course this is distance moved in a specific direction, of course, in the force of the so in the direction of the force. Right, so with FD there, then we need the units now for work. That means we have force there. We know force is mass times acceleration, so we'll need the units for mass and the units for acceleration and also the units for distance there. That means we have mass, that is kg, for acceleration meter per second squared, times the distance is meters. All right, then combining this we have kg meter squared per second squared. Then for time, we know the units for time. The SI unit for time is second. So this implies that the unit for power will be equal to the unit for work over the unit for time, and this gives us kg meter squared per second cube squared, divided by T, which is S there. Combining those two, that means we have kg meter squared s to the power minus 2 minus 1, and this will give us kg meter squared per second cubed. Right, shown, since the question is said show, this is how you get it. Okay, then now we need to move on to part B. Okay, part B is asking us to use an expression for electrical power to determine the SI base units of potential difference. So you realize that the definition of power will always change if you consider mechanics and electricity. Right, in electricity we know that right, let me just have B here. In electricity we know that power is equal to voltage times current, where the voltage is the potential difference that we are looking for. So from here we can see that V will be equal to power over time, over current, power over current. And then once we have this, now we know the unit for power. Like, let me take you back to the previous one. This unit for power will always be watt. Okay, this is a watt, and that is the same unit that we have probably for power in electricity. Okay, electricity, yes, it's watt, but the watt is derived from voltage and current. So the question is said use an expression for electrical power to determine the SI unit of potential difference. So what it means, we're just taking it from what we have on our previous question. Then that means the unit for the potential difference now will be the unit for power divided by the unit for current. Okay, now you need to to realize that, okay, we can decompose current. Yeah, we can still use the charge in time, but that will take us back. So what we simply need to use is the base unit for current, and we already have those ones for power there. So that means we are simply saying kg meter squared per second cubed divided by, what do we have there, right, amps. And this is going to simplify to kg meter squared per second cubed per amp.